Hello, everybody, and welcome to today's session on So You Think You Can Architect? Man, this is huge. Have you seen? We have more than 13,500 people at this conference. It's a huge conference, and I'm very, very glad to be here and introduce you to some interesting architectural concepts that my colleague Jan and I came up with. So my name is Konstantin Gonzalez. I'm a solutions architect with AWS in Germany, and in my day-to-day job, I help customers make the most out of our cloud services.
So as Konstantin said, my name is Jan Metzner. I'm a solutions architect like Konstantin at AWS in Germany. And we are helping our customers architecting and implementing applications on AWS. This is an architecting session. So that actually before we can start architecting, we need a system to architect, or better, we need a challenge to face. And I'm very proud that we have today here a customer of mine that faced some challenges, and he will present to you which challenges they faced and how they solved them. Welcome on stage, Michael.
So today, between the three of us, we are going to show you how you can get some new ideas for your architecture. We'll give you some new ideas that you can employ in whatever architecture you come up with. We're going to show you how to get more time by delegating away typical architecture problems. And we're going to help you worry less about security, scalability, and complexity. But before we dig into that, let's give it over to Michael.
Well, thanks, Konstantin. Thanks for having me here. Surprised to see so many fans of German television. So my name is Michael. I work for a company called Pro7sat.1, which is a large German broadcaster. And we did an interesting show earlier this year. Now I'm going to tell you about that for a few minutes. So the show was called Keep Your Light Shining. And before we speak about that, let me lose a few words on our company. So Pro7sat.1 is one of Europe's largest broadcasters. We're doing lots of traditional linear stuff. We have shows like The Voice or Germany's Next Top Model, which are, I guess, quite known here in the US as well. And we also do a lot of linear stuff. And in the last years, we started combining linear programs with interactive online applications. And the show I'm talking about, Keep Your Light Shining, was one of them. So the show was a live show, and we had 9 candidates who would perform one song. Everybody, it's his own little piece of, say, 15 or 20 seconds. 8 rounds, and after each round, one candidate got kicked out. And the online voters were the only ones that could judge who would be knocked out. And before we continue, we'll have a quick look at the show. So, what have you seen here? So on first sight, it looks like a, well, standard basic online voting, right? So it's a web application, there's a Facebook login, you could give your vote, 1 vote per candidate, and the result is somehow displayed as part of the live feed. So what's the big deal, you might say? Well, here it is. First of all, the whole show completely depended on this live voting application. So if the application doesn't work, the show doesn't work either. Then we were forced to develop and deliver the whole solution within 3 months from the scratch. And in parallel to that, the whole TV show itself, the whole show concept was under heavy development. So it was kind of a moving target that we were aiming at. And right before we were about to launch it and do the first live session, the first live show, A similar show in Brazil ended up in a complete disaster because the online voting couldn't stand the traffic. And right 1 week before we started, the largest German public broadcaster launched a show, which also ended up in a sheer disaster. Again, performance issues. So our guys in Munich, well, got a bit nervous and the pressure increased. And there's more challenges. So one thing that is really specific for these kinds of applications that have to do with live and interactive TV is the so-called broadcast delays. Those amongst you who still watch linear TV, and I know the number is decreasing every day, are used to it. So when you see a live game, be it football or whatever, sometimes it happens that your neighbor is cheering for the goal before you even haven't seen it, right? And but so far so good. But when it comes to live interaction in terms of voting for something that is going on live and inserting those votes into the live feed, there's another issue because imagine when one of those candidates who is performing his piece of the song that maybe takes 20 seconds, starts singing. It takes 7 seconds or even longer until you hear and see the first piece of sound on your TV screen. So then you listen, you make up your mind, then you decide to vote, and when you vote, the performance is already over in the studio, and the results have already been aired, right? So you would have to send your vote back through time, which is an issue, which would be a great service to build for Amazon. Then there is this load issue, because, you know, in this use case, there is no such thing as auto-scaling, because when the show starts, all the users are logging in. So it's from 0 to, well, close to 100% performance and load. So there is no time to scale machine by machine. You have to pre-warm. And you have to guess for how many people you have to pre-warm, because nobody knows. You know, it's a new TV format. It can be, you know, a huge success with millions of participants, or a disaster with a few 10K. So you can do calculations like, okay, it might be 300, 400K or something like that, but everybody you ask will tell you, please prepare for a few millions, which is what we try to do. And then there's this availability issue, because in traditional web applications, 99.999 whatsoever is more than enough. A few minutes of downtime per month is fair, even especially for a new application, right? But in this case, it's TV, it's broadcast. So if the voting doesn't work, the whole show doesn't work. You have to have a 100% availability. There is no such thing as build, measure, learn, improve in slide steps. And one thing that is also very specific and nearly broke our neck in this project was the issue of connectivity. So when we had built this whole application and we set up this super geo-redundant AWS application, then we went to the studio and we found that the TV studio and the Amazon cloud were linked together by 1 weak Wi-Fi connection. So the first thing we did was we went into a shop and bought an LTE router, which saved our, you know what, because the Wi-Fi connection, of course, went down during the first show. So with all that in mind, you may ask yourself, how would you build such an application? And the first and most important factor for me is, and that's my major learning, be as paranoid as you can be. Because as the famous Werner Vogel quote says, everything fails all the time. Whatever you build can potentially fail, so be prepared. And keep it simple, because if the application doesn't work on the CEO's BlackBerry, and yes, he's using a BlackBerry, then it's like it hasn't worked at all. at least for you as his employee. And after you have done all that, then go to AWS, talk to these guys, because they can do the heavy lifting. Thanks. When you've done all that, then it potentially works. So thank you, and over to you guys.
Thanks, Michael, a lot. Now, before we start, we will dig a little bit deeper in what such an application is doing. And keep in mind, a lot of what we are talking about is not only available for such applications, it will be available for everything what you are doing on the AWS cloud.
So let's recap what we heard in terms of requirements and background. We need to take care of the voting mechanics. We need to make sure that every user only gets one vote to cast. And we also need to figure out how to do vote aggregation. How can we aggregate those votes quickly so that the judges see the results in near real time? And also there's some time enforcement to take care about here, because all of those votes are going to come in the small amount of time that the performer is singing their song, which is only 2.5 or 3 minutes. Also, keep in mind these are millions of users. That's probably different from your typical web application, not because you have millions of users, but because those millions of users are going to cast votes in a matter of minutes. So that poses some interesting scaling challenges. And then there are the typical non-functional requirements. Everything has to be secure. Again, if you have millions of users knocking at your door, you want to make sure that your application better be bulletproof, because you don't want anybody cheating on your voting statistics. It has to be very scalable, and also has to be fault tolerant, because you only have one shot at getting that TV show right.
So let's look at the functions of such an application. First of all, you need authentication, because you need to make sure that it is a real user on the phone. Then you, of course, need to authorize all the calls on the back end. Then, well, the votes arrive, so you need to collect all these votes. Then there's the voting mechanic, which means, OK, I need to ensure that one single user has only voted once. Then we need to aggregate the votes together, and we need to persist the votes. And this is not only for the show, but also a few weeks later, we need to be able to retrieve all votes to make clear, hey, this was legal. So we need our persistence not only in memory, so, we need it on disk and really redundant.
So let's map those functions into software architecture layers. First of all, we have the client. These could be mobile phones, iPads, tablets, who are connected through the internet with our cloud backend infrastructure. And the first point of contact, which is the endpoint, is a good place to host the authentication bit and also the vote collection bit. Then we can add another layer, which we call the real backend layer here. And this is where the functions for the voting mechanics and for the vote aggregation take place. And finally, for persistence, we are going to use a database that is going to store all the votes for the lawyers to check after the show that everything was right and to document everything. OK, so let's map these let's first concentrate on the client, OK? The client should be as simple as possible. So KISS, keep it simple and stupid. The problem is you cannot update the client that fast. You need to be sure that the client that is out there in all the app stores will work as it is. So use a dynamic configuration so that on the startup, the client really uses a configuration that is done on the server side so that the client knows which backend to call. And then please use AWS SDKs as much as possible. These make sure that you can create such an application as easy as possible. So with Amazon Cognito, with mobile analytics, with SNS push notification, and all the other services that are integrated in the mobile SDKs. This helps you a lot in creating a simple application for mobile applications. Cool. Now that the client part is covered, let's concentrate on the cloud architecture here. So let's start with the real architecting part. Now, Jan, how would you start going about putting this together here? So first of all, we can combine those functions into our infrastructure pieces here. So we can combine the authentication and we can combine the collection into a single application that runs on a single hardware layer or a single piece of infrastructure. We can do the same for the back end. We can combine the logic and we can combine the aggregation piece onto the second layer running on the same infrastructure. And of course, we can stay with the database. Now, how would you build this up, Jan?
Well, we have these three pieces. If we want to do this on AWS side, we would map the endpoint to an elastic load balancer. We would have an auto-scaling group with EC2 instances behind this one. And then we have the backend also with an elastic load balancer, with an internal elastic load balancer, with an auto-scaling group and EC2 instances. And then, well, we would probably just boot an RDS instance. And, well, that's basic the architecture by the book. So if you go to our website, to the architecting part, this is the website, this is the architecture we recommend for web applications. So normally you have your web service, your application service, and your storage, so your database.
OK, cool. So how does this stack up against our requirements here? First of all, of course, this is a scalable architecture. We are using the elastic load balancer, which is elastic. We're using auto-scaling groups. That's all good. And it was also based on best practices. So who has been to an architecture class before? Can you have some? OK, so no surprises here. This is easy to set up. This is well understood. These are the good points. But there are some things in this architecture by the book that are a little bit special that we need to take special consideration of. And that is, first of all, we want to make sure that the endpoint that we implement here is really secure. And that means that whoever gets to write that application running on the endpoint better make sure that it is completely bulletproof secure here. Also, as Michael pointed out, we are going to scale from 0 to 100% in a matter of seconds. So we better pre-warm everything. We better pre-allocate the auto-scaling group and make sure that it is big enough so that it can take all the load at once. And it also helps to pre-warm the elastic load balancer by working together with AWS support. But now I have a little bit of headache with the database here, because it is easy to scale an auto-scaling group. You just tell it how many nodes to have. But it's a lot harder to scale the database. So first of all, we should take a look at the database here.
So let's take a look at the database. I mean, scaling a database should be easy on AWS. Just use Amazon DynamoDB. It will scale infinite. And you should not have any problems with scalability on that. And actually, you can do more with Amazon DynamoDB. You can move back-end logic to the database itself. Cool. So with conditional updates, you could move the requirement that a user should only vote once to the database. And actually, the database is doing this. And with atomic counters, you can just be sure that you aggregate all the votes. So even this one is moved to the database. And then we have only the endpoint, which collects all the votes, and the database, which holds everything, which updates the counters, and which ensures that a single user has only voted once.
This is great, because DynamoDB is not just a NoSQL database that scales infinitely and is easy to use. It also has these intelligent features that allow you to put pieces of your logic right into the database where they belong. So I'm feeling comfortable now with the scalability part here. But as you remember, the DynamoDB model assumes that you pre-allocate capacity units to the database. So you need to know more or less how much capacity you're going to need. And if you don't provision enough capacity to DynamoDB, you may run into a situation where you get out-of-capacity errors. And then there may be a situation where votes are lost. So what can we do here, Jan?
So there's a customer, perhaps you know him. It's Shazam. And they have found a cool solution for this. This is from a blog post at Shazam. Mm-hmm. What they are doing, they will put Amazon SQS queue besides the DynamoDB, and when the DynamoDB is out of capacity, they will write the writes to the SQS queue, and they have an auto-scaling group behind the SQS queue that is reading the writes out of the SQS queue and write it back to the DynamoDB when there's capacity. So with this scenario, the out-of-capacity problems from DynamoDB could be solved.
Cool. Thanks, Jan. So that means that we don't need to worry too much about database capacity and capacity provisioning. We always have SQS as a buffer who can help us out in case we didn't provision enough capacity here. But now the architecture is kind of looking a bit more complicated than I expected it. We got rid of an auto-scaling group, and we were glad. And now we introduced it back again. So is there a way to simplify this even further?
So let's look a little bit on the client side, because actually Amazon SQS is an AWS service. You can access SQS from outside the Amazon cloud. Actually, you can access this directly from the client itself. Then we have Amazon Cognito, which is the authentication part, which you need for accessing Amazon SQS. And let's look on the client side, how this is done on the client side, because we said, okay, hey, we need a real simple client. First of all, you need to bring up a login screen. So, for example, with your favorite authentication provider, be it Facebook, for example, this is the Android code from the Facebook SDK to bring up the login screen. Mm-hmm. You log in, and in the background, Facebook will give you a Facebook token. Then you create a Cognito credentials provider from our mobile SDK, and this will handle all the authentication underneath. Mm-hmm. Then you add the Facebook token to the authentication provider, and underneath Amazon Cognito, so our backend, will provision temporary access credentials for you. And then we need to call the SQS queue. So these are 2 lines of code to send a message to SQS. And underneath, Cognito ensures that the call is authorized. And before that, you have also set up everything correctly so that you allowed these users to access SQS. Mm-hmm. And this is very simple to just call SQS directly from the client. And well, this is not only possible for Amazon SQS. You can use this for all the shared services. Being S3, for example, or perhaps some DynamoDB stuff, you can directly access all the shared services from the mobile client. Together with the mobile SDK and Amazon Cognito, it is seamlessly integrated. And only a few lines of code, you need only a few lines of code to do this.
Cool. So I guess that now our problem got a lot simpler. We can now directly put SQS in front of our whole architecture. We can use SQS as the endpoint for our stuff. So we don't have to implement our own endpoint. We can just use what's already there from SQS. And this is great because you can use this with mobile phones. You can use this with a website using the JavaScript SDK. You can use any client and teach them how to talk to our AWS endpoints directly. You don't need to implement your own protocol. You don't need to implement your own service here at the endpoint. And the other great thing here is we don't have to take care of endpoint security. We don't have to worry that much because it's the SQS team job now to make sure that the SQS endpoint is secure. And they already did their work. They have a lot more knowledge about how to secure APIs than I do and than any of our developers at our customers do, because that's the day-to-day job. They need to make sure that SQS is always secure. And they also can make it so that SQS scales for us. So we don't need to pre-warm anything. We don't need to pre-warm AELBs. We don't need to pre-warm auto-scaling groups. We just use SQS. It's already pre-warmed. It's already accepting millions of messages all the time. So that's great. We just made our life easier by just putting SQS in front of everything. And we like this architecture so much that we gave it a new name. And we came up with this name, QSQL, kind of like Cloud School, but with Qs, QSQL. We are talking to marketing. Maybe we can trademark this name or something like that. But we like this architecture very much because it takes away so much worry from our minds. And the other cool thing about this architecture here is it's 100% decoupled. That means that The client sends messages into the queue and can then forget about everything and concentrate on whatever clients do after they send their message. And then we can consume those messages from the SQS queue, from our own backend here, at any rate. So if we didn't scale that backend far enough, then it's no problem because SQS will store all these messages for us. No message is going to be lost, and we can always consume them lazily. So this piece here can scale lazily. It doesn't have to be there all the time at a super high scalability here, and it is much more forgiving in terms of operating. So let me introduce you to my customer here, which is a company called RTL Interactive. It's another large German European broadcaster. And they implemented the following architecture for one of their own TV voting superstar shows. So you will see that at the bottom is our beloved QSQL architecture. So this is where the client talks to the SQS queue, and then there is an auto-scaling group that processes the votes and then feeds them into the DynamoDB database at the bottom right. And this is exactly how they did it. Back then, they didn't have access to Cognito because we launched Cognito only a couple of months ago. So when they designed this architecture, they set up their own Elastic Load Balancer with an auto-scaling group to generate credentials through the AWS Security Token Service. If they were to do it again today, they would just use Cognito instead of the pieces at the top of this diagram here. And they also used the Security Token Service, or the mechanism that Jan explained to you, to teach the client to upload their own images into S3. So when the user registers, they upload a photo of themselves, a profile picture, and the client can upload the profile picture directly into S3. No more architecture required to do that. And in fact, this customer liked SQS queues so much that they used their own SQS queue in the backend to schedule some backend task processing. So whenever there is a new user that registers or some other work to do, they just push messages into the queue and let those auto-scaling group process these messages, kind of like a lightweight workflow system. And when setting up such an architecture, it always pays off to use Amazon Elasticache. In this case, the customer used Elasticache to have a cache of the information whether a user has voted already, so they could offload some of the work from the DynamoDB table, saving them some money.
Okay, keep in mind, everything what you heard today, you can use for any applications out there. It could be also a financial application or some other application. It doesn't need to be a mobile application. It can be a web application or so. You can directly access the services, and Amazon Cognito will authorize this and will get you a login if needed, or even has support for unauthenticated users. And you can directly attach all the services we have to your application. And yeah, it makes it much easier to architect and implement an application itself. So let's look beyond the architecture itself, because the architecture is one thing, but you need to take care for a lot of other stuff as well. So first of all, please plan thoroughly. Make the right assumptions. You have heard from Michael. They prepared for 500,000 users, but should be prepared for 3 million users. These are large differences, but you need to make sure that the application has the right scale. Try out many variants, because you don't need at the beginning, you don't know at the beginning which will be the best variant, where you might have some problems or not. So you need to try it out. And then think through your stuff. Think about the edge cases you might face so that you know what's going on in your application itself.
Another thing you can do is make sure you get an extra set of eyes on your architecture. Never do it alone. So in my case, my customer, they used a partner to get them up to speed in programming SQS and programming AWS so that they can concentrate on their own application much better. Please talk to us AWS Solutions Architects. It's our day-to-day job to help you set this up, to help you think stuff through, and to help you come up with new ideas on how you can simplify and make your architecture more powerful. Use AWS training. I was very glad to see that so many people of you have visited already an architecture course. Take advantage of AWS training, because a lot of the best practices are taught there. And whenever you're doing these complicated things where everything has to work right, like during a TV show, a big launch event, when you buy some time on the Super Bowl, or whenever you do something that is really a little bit scary because it has to work, please do involve AWS support. There's a special service that they provide, which is called Infrastructure Event Management, which means that 4 weeks before you start, you're going to get assigned your own technical account manager. He's going to go through everything with you. He's going to prepare you for everything. He's going to run benchmarks. He's going to be there out and on the telephone while you have your big launch, and also help you whenever something comes up that may be unexpected.
Okay, regarding testing. Please test early. Please test at least 4 weeks before your event, but actually you can test during your development. Do an end-to-end test, both do a functional test and also a load test. And if you want to do a load test, I would recommend WRK, which is a perfect tool for doing HTTP-based load tests. And just boot up some EC2 instances. Install this tool on the instances and start load testing your application. And for example, in this case, I even tested SQS to show the customer that SQS is able to handle so much votes in a few seconds. And it is easy to test, and you get good results with it.
Great. Now let's recap what we learned during these 2 projects. And I would say the one big outcome here is that the best architects are the lazy ones. You may think that good architects come up with these brilliant, super complicated diagrams that only fit onto 5 to 7 slides or something like that. But sometimes the best architectures are those that are super simple, like our new Q-School architecture here. And the lesson here is you can offload a lot of your architecture work to the fine people in the SQS team, the fine people at the S3 or other teams who put together those combined services that you can just use and even teach your clients to use directly instead of putting architecture in front of that. So that means that AWS is much more than just infrastructure. It's about making your lives easier also on the architecture side by giving you building blocks that are already very powerful and that you just need to plug and play together in a very simple way. And that gives you much more time to concentrate on your innovation, on your application, on your invention, on your ways to differentiate yourself from the competition and maybe disrupt your market through your new idea. So thank you very much for listening. We really hope that we could show you some new architectural approaches that will make your life easier, securer, and also much more scalable. And we are going to be available for some questions down here at the stage.
Yeah,
thank you very much.
Some more thing. Tomorrow is a mobile workshop. So,
yes.
If you want to play around with the core connector thing, with SQS and so on, please go there and try it out yourself. You will see how to implement such an application.
Okay, with that, thank you very much and see you at the party.